All right. Good morning and happy Tuesday. Um, it's nice and brisk outside, so please stay warm as you trek across campus from various corners of the campus to class. Today, our purpose is to continue on with our conversation, but our focus today is going to be on so-called problem-solving agents and considerations for them. But before we begin, the usual administrative bits. The reading has changed. Please make sure you're staying up on the reading. In the syllabus, I have the entire semester mapped out, making sure you're engaging with the book as we cover the various materials. And so we're pivoting now to material in support of the second project, which will be on problem-solving agent for the Pac-Man environment. Also, assessments project number one is due this evening. As of last night, I think there's 8 or 10 of you who haven't. Please jump in. The water's fine. Don't wait to the last minute. What happens once the due date and time is reached, the assignment goes away and I won't accept any more submissions. So please make sure you're getting on things right away. I do have office hours today from 10:30 to 12:30. I'll be in my office, room 326. Maybe I should do it in my lab. I don't know. Lab or office? Probably my lab. Room 105, which is the robotics lab. So you're welcome to just come by if you have any questions. Okay. All right. Any questions about project number one? About grade scope? None? Nothing? No? Okay. All right. So why don't we just move forward? Does any my daughter, who's 13, she's turning 14 next month. And, I always tell her, don't be in such a rush to grow up. Enjoy now. And I'll offer that advice to all of you. Enjoy now. And so I partake in dad jokes, right? And as much as she groans and rolls her eyes, which 13, soon to be 14-year-olds do, she still asks me to tell them. And she says, I bet you won't say one to your class. I'm like, well, hold my Coca-Cola, right? So clam chowder. It's nice on a cold day like this. Does anyone like clam chowder? Yeah. Fish chowder? Some don't eat clams. Yeah. Okay. Well, clam chowder is a nice, warm, wholesome meal, especially to be enjoyed on a cold day like today. Is there anything missing from this clam chowder? Is there anything missing that you can see? What's missing? Chris? The oyster crackers. How can you not have clam chowder without the oyster crackers? The two go hand in hand like peanut butter and jelly, right? Um, Now, when I was a kid, I didn't get a lot of American colloquialisms, right? I was born overseas. And so I've always been a fan of culture. So we're missing the oyster crackers. So my question to you, how did the patron describe the clam chowder that didn't come with the oyster crackers? How did they describe this? No? Any ideas? No? No. It's crack-a-lackin'. All right. Thank you. I love this one. So, crack-a-lackin', I consulted the Urban Dictionary, being a fan of culture. Um, it's an expression that originated in the hip hop community, genre of music, and also urban areas. And it's used or sometimes referred to as a Snoopism from Snoop Dogg, the rap artist. I don't remember his actual government name. But nonetheless, no one really knows where it came from. But, this particular artist has popularized the phrase. And it's a way of asking people how they're doing. So someone might say, yo, what's crack-a-lackin', right? Um, I remember when I was a kid, somebody would say, hey, what's up? And I literally didn't understand what they meant. Huh? What? So you could imagine, navigating middle school, which is not always the most pleasant of environments. Okay. But nonetheless, I love Costco. Anyone shop at Costco? I love Costco. Or are you BJ's? That's like Coke and Pepsi, right? The two warring factions. For those of you unaware, Costco is a discount warehouse-based store. You buy a membership, and it affords you savings. And typically, when you buy items, you buy big units of these items, and it affords you savings. And so the closest Costco to this area is Waltham, but Waltham is a huge pain in the butt to get to. I don't like traffic. So I drive to Costco in Nashua, New Hampshire, right? I run for the border and then also get to enjoy tax-free shopping. Having lived in Delaware for 14 years, no, 15 years before coming here, you get used to tax-free shopping. So tax-free is always good things. Costco also has a reputation for treating their employees very, very well, both in terms of pay and sharing in success of the enterprise. But you can look that up. And so this weekend, of course, this is a view, and I do have a phone mount. That wasn't like having my cell phone out while driving on Route 495 and then Route 3. Um, and this is what the weather looked like. And so it was snowy. So when it's snowing outside, inclement weather, it wasn't horrible. You slow down significantly, you exercise some caution, you keep your distance, and you just, turn on some nice tunes and just relax and enjoy the beautiful scenery. Okay. And so I was relaxed, and my car, it's not an autonomous car, but it has a couple features that you might consider autonomous features, right? It won't drive itself unless you put your knees on the steering wheel and say, look, ma, no hands, right? But don't do that. I'd never do that. I was pretty comfortable, but the autonomy features were freaking out. It was basically, I can't see what happened. The radar cruise control is unavailable. The pre-collision system is unavailable. The forward camera system was unavailable. And the lane departure warning system was unavailable. So, as aptly put by Pac-Man, it was game over. Nope. Uh, 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 it's not working. Did you hear that? It was just in my ear. Oh, come on. All right. It was the Pac-Man death sound. So much for that punchline. So, nonetheless, it was game over, but I still drove home. I was still able to make decisions effectively. And this goes back to what we discussed last week about being able to make decisions and being able to reason in spite of what wasn't a particularly horrible snowstorm. It was, just normal. Okay, let me see. So, how was I able to do this? I'm kind of a learning agent, right? So let's think about this in the context of the components of a learning agent. I'd like to hear some of your thoughts. How was I able to still drive even though all of these autonomous features kind of gave up? It freaked out. How? I was able to do that. What are your thoughts, Robert? Previous experience. And what does that experience allow me to do? You said in all sorts of conditions, right? What was I able to do with that experience? What do you think? Act, adapt. This word adapt. Okay. And so with this experience, was I able, what was I able to do? I was adapting, but what did I do with this experience? Was there some data structure I made use of? This experience, what does experience do for us? Adapt, yes. I applied that experience and I did other things, but what I chose to do was more appropriate for what I saw based on this previous experience. So there was something in there. Okay, this learning. Any other thoughts about that? Any other thoughts? Experience and adaptation. No? Yes? Chris? Hmm. Okay. So I could get the snow off, but as the agent, yes, the autonomous features utterly failed, right? Um, but yet I was still able to drive home. I was able to adapt. I had an understanding of how the world works. If I drove the same way on the highway during these conditions as I would on a dry, sunny day, it probably wouldn't work out very well. And consequently, on the way home, I went to Solomon Pond Mall, and it was an opportunity with the big empty lot to do donuts and, try out the dynamics of the car, trying to build a model for how the world reacts in this context, to Robert's point, helps me to quote unquote adapt, right? And so the critic here, let me ask you, what was the critic in my mind doing? What do you think? What was it doing? What was it saying? Let's hear some of your thoughts on that. If you were driving in the snow and a storm, rather, if you were driving and a storm came, what would your mind be telling you? Yes, Luke, slow down. Slow down. Why? How do you know that? Be the experience. So your experience tells you, even from when you're walking, right? Not even necessarily driving, that when these conditions occur, it's a lot more slick. You can slip, so you need to go or proceed more slowly. Okay. Um, Problem generator. What do you think the problem generator in my brain might have been doing in this instance? Elliot? Hmm. Hmm. Aha. Now, do those scenarios, like what you mentioned, Elliot, did they necessarily happen? But I imagine they happen. Absolutely. So I'm proposing different alternatives based on my experience. Ooh, there's a semi there. It might have snow on top of it. It'll blow, and I can't see what's in front of me because that snow will coat my windshield. Let me let off my gas and back up more so I can react a little bit better in time. There's a car that's speeding on my right. I guarantee they're going to cut in front of me. So let me let off my gas even more to give them the opportunity to do that. So I won't have that element of surprise. So I'm proposing different alternatives and evaluating them, regardless of whether or not they occur. And if a new percept arrives that is on that trajectory of that alternative, then I'll already have a sequence of actions that I can try in order to effectively reach that goal. And in this case, the goal is to get home safe. Okay. Any questions about this? No? And so, yeah, autonomous systems, like we said last week, there's a reason why you see them in Arizona, in California. There are a lot of practical issues when you introduce inclement weather because it's changing in a large way the environment acts back when you act in your environment. Moreover, physical models about how cars drive, all of those physics, there's a lot of unknown stuff because traction is different, response is different, rolling friction is different when you introduce moisture, ice, snow, etc. Okay? All right, any questions about this? And so one of the key takeaways is to really characterize the environment because the characteristics of the environment are going to dictate the type of agent architecture that will be effective for solving problems within that environment. Okay. And so autonomy is certainly not some magic solution. And there's a reason why you don't really see autonomous cars, truly autonomous cars, level four, level five, in environments where you have inclement weather. Okay. All right. And so certainly I got into my neighborhood and made it home safely after doing donuts in the empty lot in Solomon Pond. mall. Not only is it fun and be safe when you do that, it has to be an empty lot, but you also gain experience about how your car behaves in this environment. I bet you wouldn't think I'd be doing donuts in a parking lot. Yes, I do. I'm that type of person. All right. Nonetheless, okay. So let's think about this idea of proposing actions. And the goal is some concept of, or concept, syllable, some concept of a notion of quote unquote correct actions. And so let me pose the question to all of you, get your thoughts. Is the correct action immediately known? Let's think about it. Do I know what the correct action is um, on that highway picture or in this picture or just driving in general? On Main South, you really don't know, right? But is the correct action immediately known in something like the driving task? Yes, Chris. Yes. Hmm. Ah, I don't know what it is. Okay. So I have to make some considerations or plan ahead. Okay. Good. So what do I consider if I don't know the correct actions? I have to consider stuff. Consider what? Let me ask the question to all of you. Luke? Clear definition. That's an important point. We don't always have the goal available to us, and there are different types of agents. One where you have this notion of what the goal is, and one where you don't necessarily. And today our focus is going to be on those environments where you don't necessarily know what the goal is, and then we'll relax that one where you have some notion of what the goal is. But it's a great answer. What the goal is. Anything else that you might consider? Hear your thoughts. Share your thoughts. What do you consider? Yes. Oh gosh. I remember everything about you, but I can't remember your name. Could you tell me your name? Sorry. Julia. Did you say Julia or Julia? Julie. One more time. Julia. 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 Thank you. Julia. One ear is covered up. So, Julia. Mm-hmm. 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 Okay. So Julia, right? And I say your name again specifically so I can try to burn that into memory. Julia says that you evaluate things about criteria or scores rather about the things that you could possibly do. Okay. Great. So you consider your actions. But it's not just your actions that you consider. You also consider how that might produce a transition of states in the environment because you're acting in the environment. So as you act, the environment acts back. And as a consequence of your actions, you're inducing a change in states in the environment. So in your consideration, okay, it's what you do, but what you do has consequences on the state of the environment in which you are situated. And so a particular type of agent called a problem-solving agent, it arrives upon a sequence of actions, and the computational process that it uses to do this is search. Okay. Okay, end of class. No joking. Is search. And so let's take a look more closely at various considerations of problem solving agents. Well, you need a representation. And with this representation of state, this representation can arise in roughly three different flavors. An atomic representation, that means that the world state is represented as a whole. One particular quantity or value or configuration represents everything in the world. The position of your agent, the objects in the environment, the position at that time instant of all the other agents that might or might not be in the environment, etc. Another type of representation is called a factored representation. With a factored representation, you have a set of summary variables which together take on values, and it's that conjunction of values of our summary variables that comprise the state, the relevant state for the environment in which you're situated. And then we also have structured representation. In structured representation, that tends to be more detailed. You're representing interconnections between components. And with the structured representation, you can reason more intently about what's happening in the environment. But the price that you pay for that level of descriptiveness is increased computation in order to arrive upon things that you need. And so when you solve a problem that has an atomic world state, that's a so-called problem-solving agent. And that problem-solving agent is going to use search to arrive upon what is the quote-unquote right action sequence in order to hopefully accomplish the goal. Now, in this particular representation, it doesn't have a notion of distance to the goal, and therefore the goal in particular, but it will still arrive upon some sequence of actions, that's some notional best action or sequence to accomplish a goal. And then for the latter two types of environmental representation, that arriving upon the right set of actions is called planning, right? Um, it's a formal word, and it means to make consideration for a sequence of actions considering how the environment acts back in order to achieve some notional goal. Okay. Any questions? No? Luke. An action sequence, right? So it's not just a single action, it's a series of actions. The first action, the second action, the third action, and it's doing so in order to produce a goal state in the environment. And so it's not just a singleton, it's a sequence. But each action within that sequence, it's going to produce some state in the environment. And so the question is, what is the right set of actions interleaved with states that is going to achieve reaching the goal configuration? Did I answer your question? All right. Any other questions? No? All right. And so with your environment, we talked about different axes of characterization of an environment in which your agent operates. We said it could be episodic. That means that each experience is self-contained. We talked about single agent versus multi-agent. In this case, for problem-solving agents, we have a single agent. The state is fully observable. There's nothing hidden about the environment. It's deterministic. That means the next state that the environment goes through is completely determined by the current state and the action played, right? It's static. That means that there's no determinism in the environment. And when you consider an action, the environment does not change while you're deliberating. It's discrete, so the values that you measure are either finite or countable. And it's also known, meaning that the physics of the environment are not hidden from you, right? You don't have to do any learning from experience, as was alluded to earlier. Okay, and so the agent considerations we have, there's two types of agents. One's called informed. That's where you have some notion of, are we there yet? Are we there yet? An estimate of the distance to the goal. For example, you're on a road trip and your GPS says you have about 20 miles left. You have 7 miles left. You have 2 miles left. Another is so-called uninformed agent, and that's where you have no knowledge of the goal, right? Because it's different when you try to uncover sequences of actions. Okay. Any questions? No? And so let's take an example, and this is all from the book, and it's a navigation example. Suppose you're planning a Romania vacation. Now, prepping for this, I was like, man, this place is beautiful. I don't know anyone from Romania, but if I post this video and it makes its way to somebody in Romania, you're welcome to invite me. I'll gladly go. It looks absolutely beautiful. Suppose you're going on a Romanian vacation, and if you know Romania or speak Romanian, I'll apologize ahead of time for my pronunciation of these cities because I just don't know. And let's imagine you're in the city of Arad, which is on the left, and you want to get to this place called Bucharest, the capital city, as I understand. Now, of course, you don't know Romania at all. All you know is that you're in Arad. Okay. So you set to the road, and leaving Arad, you see a three-way street sign. And the street sign has three roads out of the city of Arad. But the three cities that you see on the sign, none of them say Bucharest. Okay. So you have no idea which way to go. Let me ask you, how do you proceed? What do you do? If you have no idea about the layout of Romania and all you see in the moment is this three-way street sign, what would you do? What could you do? Any thoughts, Chris? Hmm. Imagine oops, you don't have a phone and you don't have any other. Yeah, you would use Google Maps, right? But if you are an agent and you're in this particular environment, Nikki. Hmm. Okay. Let's take the egocentric view or from the perspective of the agent. You don't know anything. All you see in the moment, I'm in this location. I can go straight, left, or right. And the cities for straight, left, and right, none of them say the word Bucharest. What do you think is the only thing that you could do? Alexander? Pick one and hope you see another. Absolutely. That's all the information you have. So you flip a coin, a random guess, or you flip a three-sided polygon. You randomly guess, pursue one, and then see how you did. That's the best you can do. Okay. So that just motivates the idea that you need a map. The map tells you something about the geometry of the layout, right? If you don't have a map, the best you can do is try and see where it leads. And then if you try enough action after action after action, eventually you'll get to Bucharest. It's not the most efficient way of doing it, but it's effective. It works given the context that you have. Now, it's really important when you think about these scenarios, not to think from your human example, to think from the agent example, the so-called egocentric view, and all the information that's available to you at the current moment, right? The less information you have, the more exploration and building of using experience to build understanding of how the world behaves. This thing is adjacent to that thing is adjacent to this other thing. Okay. So this is the map. It's from the book. And your beginning city is the city of Arad. And your destination city is Bucharest. And you have this street sign, and there are three roads out of Arad. And so just to mark that for you on the map, let's use a bright color. This is the city of Arad. Okay. And so we have three roads out of Arad in this map. Are these the only roads out of Arad? No, they're not. But just in this particular example, this is the information that you have. Okay? All right. And so you have your street sign and you have three roads out of Arad, and none of the cities on the street sign are Bucharest. So you could do a random guess, but now with this other information, this geometric information, we're assuming a map. So the idea then in our problem solving process is we form a goal. Bucharest is going to be our goal. Okay. And when you set a goal, that has the impact of limiting your actions. It helps you organize your behavior. This sequence is a quote unquote good sequence because it visits Bucharest. This other sequence you propose is a bad sequence or a less desirable sequence because it doesn't intersect or visit Bucharest. And so with the problem formulation, the idea then is for the part of the world or the environment that's relevant to the problem solving, i.e., achieving that goal state, what are the necessary states that you visit? And what are the necessary actions that get you to those states as the environment acts back? Okay, does that make sense? Any questions? No? All right. And so you simulate these actions in a model. Now, part of the architecture, because this is a discrete environment, we can act on the world and it's deterministic. So we know what our next state is based on solely our current state and our action. Okay. So we can use that to effectively run a simulation. If I take this action, what's going to happen? If I take that action, what's going to happen? If I take the other action, what's going to happen? Now, given the next state, you can play that forward in time for a number of steps. And then eventually, at least for this map, one of those sequences of action, environment, one of those sequence of actions is going to lead to an environmental state, which is being in Bucharest, our goal. Does that make sense? Now, sometimes it could be the case that regardless of all of your different simulations of actions that you take, you're not going to reach your goal. So that means it fails. Sometimes these agents fail to find a solution, and that's okay. All right. So you have to do something else. Maybe there's something missing from how you characterize the environment, and you need some other things in play. Okay. Any questions? No? No questions? Okay. I was trying to get a moment to pause for some water. Okay. So you play actions. Once you arrive upon a solution, solution is one that achieves the goal, is a sequence of actions that achieves the goal. Once you identify a solution, you execute it. You just play those actions. Okay? All right. Any questions? And so the environment in this case, it's observable, is deterministic, and the physics are known. So once you find a solution, you just ignore everything yet you perceive as you execute. You basically determine a solution, close your eyes, and just execute those actions. For this type of environment, that's guaranteed to achieve the goal. That's in robotics community called open loop execution, right? You're not taking in any feedback from the environment. The dual of that is closed loop operation. Closed loop can adapt because it's paying attention to the percept sequences along the way and can adjust the sequence of actions, maybe choose an alternative or slightly different sequence of actions should the percept sequence along the way during execution say that something's happening that will prohibit you from achieving the goal with your current sequence. Okay? And so, any questions? No? I think I have an example in here. Anytime you introduce non-determinism or partial observability, aspects of the environment that are not directly modeled, and non-determinism, you're relaxing that assumption that the transitions of the states in the environment are completely determined by the current state and the action, right? Um, and so in the case of this relaxation, you have to do some branching. You have to consider alternative action sequences. And then once your percepts arrive, your sensations from the environment through your sensors, you can recommend or pursue an alternative future, an alternative sequence of actions. Does that make sense? Any questions? No? All right. So let's take an example. Let's say you want to go from Arad to Bucharest, and you decide to make that transition along the road segment between Arad and Sibiu. I'll just say it that way. Again, I don't know anyone Romanian, so to Sibiu. Okay. And let's say you proceed down the roadway, and all of a sudden, for whatever reason, you see a sign that says road closed. You can't pursue that alternative. Okay. So you have three different actions you can play. One alternative was that road directly to Sibiu. Another alternative is that road to Zerent. And you know from the map that eventually you can get to Sibiu and then ultimately on to Bucharest. So given that you encounter in the second alternative, you have three branch points that you can pursue. You see the road sign in your percept sequence, and you decide to pursue the other alternative. And so in that case, well, road signs being put on the road to block the road because something happened, that's partial observability. You didn't have that in your model. But because you're paying attention to your percept sequence and you have a set of alternatives for action sequences, you can go back and then try a different sequence and adapt to what's the prevailing environment is. Now, you might try that again the next week, and that road sign blocking it is not there. So you just go straight to Sibiu and then on to Bucharest. Does that make sense? Now, this is specifically for the case that you have partial observability or non-determinism in your environment. Okay. So you can, in some agent architectures, recommend actions based on the prevailing context, namely your percept sequence as you execute a plan. Okay? Any questions? No? And you've seen this with your GPS, right? It says rerouting, or if you have a Toyota product, it tries to make you go there anyway, right? But any questions? No? All right. We're going through this faster than I anticipated. Excuse me. And so we define, excuse me, a search problem, and we start with a state space. Now, the state space is a set of all possible states that the environment assumes. This is assuming full observability. If you have partial observability, you need to deal with things that you have not modeled. Okay. You have an initial state. That's that state where your agent begins. Now, in some environments, your initial state is a prescribed configuration. In other environments, like the vacuum world example, you can start in any initial state. And your goal state is either a single state or a set of states that define some property. And so when you say is goal, right, that might be in this case, my location is Bucharest, okay? It could be a set of attributes that you're checking for properties associated with a goal state. So goal doesn't have to be a singular state. It can be a set of states that your environment may assume. Okay, any questions? No? All right. And so you also have an action set. And in the pseudocode, you call action, and it's indexed by parameter, which is the state, and that returns back a set of actions that the agent can take in that particular state. Now, the action set can be the same for all states, but in many problems, it can be different across the states depending on where you are in the environment or the configuration of your environment. And so in this example, a Romanian vacation, the action set for Arad is to either take the road to Sibiu, to take the road for Timisoara, or to take the road to Zerin. And again, I apologize for mispronunciation. I have no idea how to pronounce them. I know Bucharest. Then you also have your transition function. Your transition function encodes the dynamics of the world. It's indexed by the state and the action. And what it gives you is the state of the environment as a result for taking the specified action in that specified state. And so this transition function result, if I'm in Arad and I take the action to Zerent, my next state is going to be Zerent. Okay? All right. Any questions? No? All right. Excuse me. And then you also have a cost function. And that cost function is an evaluative score, and it tells you an amalgous number called a cost, or a goodness score, if you will, for taking a particular action. It's indexed by a triple, the current state, the action you take, and S prime, the next state, as a result of taking that action. And so sometimes in some problems, the action cost for each instantiation of these three values is the same, uniform cost. In other problems, it's not. And so this cost function reflects your performance measure. You could say minimum time. You could say minimum fuel. You could say some notion of minimum cost. It's entirely up to you to define the action cost. Now, this is your evaluative measure, and as such, it's going to impact the sequence of